So we saw a few attributes in the previous class. Some were well known, mandatory, and one of them were well known, discretionary, and the other one was non-transitive, MAD, and the other one was Cisco's standard. So it was not under any category. Weight is not under any category. MAD was optional, at the same time non-transitive. Local preference is well-known, discretionary. Origin, MAD, and origin, AS path, and next hop were well-known and mandatory. And we learned the meaning of each attribute. Local preference mean what? It is local to the autonomous system. Weight is local to the router. MAD is only during the dual home scenario. The neighbor autonomous system will impact by configuring us. Neighbor autonomous system will impact us by configuring MAD in choosing our path. AS path, by default BGP will advertise the AS path. Next up, definitely every protocol advertises. Weight, we configure it on one particular router. If that one router wants to take different decision, weight is local to the router. Now we have come to a very important page where a lot of people have got a lot of misunderstanding. This page will break those misunderstanding. I'm talking to those who already there in the networking field, who knows BGP but not clearly. They have a lot of misconception, misunderstanding. This page will break all of them. BGP's forwarding table usually has multiple paths from which to choose for each network. That's what BGP table is. When I typed show IP BGP yesterday, when we did the lab show IP BGP, we were able to see that 55, 55, 55, 55. And we were able to see multiple paths. One via router 2, the other one via router 4. So for each destination, BGP can show you all paths in the BGP table, otherwise BGP forwarding table. But BGP will not use all paths, or it will not use more than a path. It will use just one path. Why? BGP is not, NOT. This is what people should know. Will BGP do load balancing? No. Sorry. BGP is not designed to perform any load balancing. Even if you have two paths with same autonomous system jump, same weight, same local preference, same everything, BGP will not do load balancing. It will find one good reason to say this is better than that. All look same. But one reason, BGP will say one reason and say for this reason I will not use that path, I will use only this path. So BGP will eliminate multiple paths, any multiple paths, until it attains single best path, just single. Yeah. So it's like two cars kept in front of you, two brand new cars. Both look alike. Same wheel size, same color, same steering wheel, interior, same. Everything is looking same. But you will have only one car because you are one man. You cannot drive two cars at the same time. You just buy one car saying this car is something different from the other one. For the seller, for the vendor, it may be same. Everything is same. But you, when you choose, when two cars are too alike, you're going to spend a big money and buy that car. So you will have one small reason in your mind. You may not say out, for that reason I'll take this car. Maybe that's the first car that you saw when you entered the showroom. The other one just came and they stopped there next to it. First is the best, something like that. Or you may like that a number, the engine number, the chassis number, it's something meaning to you, connected to your life. Maybe your birthday and the engine chassis number. Something like that. You will pick one silly reason and say, this is the car that I'm going to take. I don't have any confusion. Likewise, you may have multiple paths. BGP will have one clear reason to say, I'll need only this single path as the best path. See, BGP will not focus on a bandwidth or a delay or any hop count to choose the best path. The paths are not chosen as per any of those things that we see in IGP protocol. BGP only focuses on the attributes, your policy that you have configured. Alright, so three things here we have seen. One, BGP will have multiple paths in the BGP table. Two, even though you have multiple paths, all the paths are too close, similar. Even then, BGP will pick only one best path, and it will have a reason to say why I pick this path. BGP never focuses on bandwidth. If it focuses on bandwidth, there are chances for picking two paths. But BGP never focuses on bandwidth or load or delay. It focuses on the policy. To choose a path as per policy, it uses attributes. It's not like 3 or 4 attributes. You see how many you got. So it can easily tell for this reason, for this attribute, there's a tie break. and I'm going to use only this path, single path. Yep. Next, now only one single best path is taken, means selected, left out after eliminating all other paths. Only that eliminated, that best path, not eliminated one. All are eliminated except one. Even though we got multiple paths, only one path will be elected. That elimination will be using that attribute. And it will eliminate all the routes and pick only one single best route and put that route into the routing table. But routing table also has got some constraint. What it is, it decides to use the route given by the protocol whose administrative distance is lower. See, if IBGP gives a route, what will be the administrative distance? 200. If OSPF gives the same route, it will be 110, which is lower, OSPF. So, because BGP is not because the BGP is giving, routing table is not going to immediately take it and use it. Routing table also has got some constraint to evaluate administrative distance. If route given by EBGP is received, definitely this will be preferred because EBGP is just 20, OSPF is 110. So what I'm coming to say is, after BGP finishes its path selection, routing table will also, the routing table manager also evaluates. And if the administrative distance of the giver is lower, and if it is BGP the one which is giving, then BGP route will be seen. Otherwise, the other protocol, if it is OSPF route will be seen. Next, the route from the source with the lowest administrative distance is what going to be installed into the routing table. Please ask me question if you have any from this page. Important page again. I was telling that even if you have multiple paths, BGP is going to eliminate and pick only one path. That elimination is based on this attribute. First it will check if there are two routes. First it will check whether both the route has got valid next hop. That's attribute number 0. It will check whether both the routes are via reachable next hop. If yes, then there is a tie, both are valid. So what is the tiebreaker? It will check whether we have set any weight. You remember yesterday when we did the lab, I said wait for one neighbor. Even though that neighbor was showing a long route, packet was going via that route. Route was showing via that route. Why? Before AS path is checked, what is checked? Weight will be checked. If there is a tie break in weight, it won't consider the other attributes. It won't worry about this attribute because there is a weight, a tie breaker. Yep. I told you for weight highest is preferred. What is the default weight?
No.
0. Correct. Default weight is 0. Highest is preferred. Weight is local to the router. We learned this. Next. If there is a tie in weight, then it is going to pick a path whose local preference is high. I told you local preference is within the autonomous system. It's for all the routers in that autonomous system to make a decision. If there is a tie in weight, it will pick the local preference as an option. Next. What if local preference is also a tie? Means we did not configure. What is the default local preference? 100. We did not configure at all. So there will be a tie. Weight we did not configure. Local preference we did not configure. Now it will check whether one of this neighbor provides, or one of the next hop is 0000. See, this origin code is what you learned earlier. But this one I have shown you in the BGP table. I showed you and said if you have next hop as 0000, which means those networks are from this router, the local router. You no need to go somewhere outside to reach that network. You have it right on the device itself. What if you don't have 0000 as the origin? What if none of the networks are local origin from the local router? It is coming from somewhere. Now it will compare the AS path. See, after checking all this, it comes to shortest AS path. So now you remember why. Now you understand why yesterday, even though the AS path was too lengthy, too long, when I said weight, the decision was made based on the weight, because weight attribute comes on top. Only the fourth attribute is AS path. You need to understand this very well. This attribute order is important. If attribute number 3 is a tie break, it won't go to 4. If attribute number 6 is a tie break, it won't go to 7. It won't worry about 7. Right. So, if there is tie in AS path, then it will see whether it is I or question mark. You remember? Question mark I. One neighbor is giving with I, the other neighbor is giving with question mark, and there is tie in the all first 4. Then what it does? It chooses the path whose origin code is I. See, try to understand these things as much as possible, but I'll be demonstrating this. That will give you much more clarity. But now understand the lowest origin code. I is lower than question mark. Lowest origin code is preferred. You remember I means what? Using network command it is advertised. Question mark means what? Redistributed. Advertised is more preferred than redistributed. Fine. Next. If there is tie in all this, and then when you have multi-home, no, sorry, not multi-homing, dual homing, only then this will come into picture. When there is tie in all the above and you also have a dual home, now router will check whether I am receiving any MED from my neighbor autonomous system. If so, I prefer the path via the neighbor whose MED is lower. Condition is same autonomous system is connected with multiple connection. Dual homing, not multi-homing. If there is tie in this all 6, then it comes to 7. 7 says if you will have an eBGP neighbor, then prefer the eBGP neighbor and eliminate the iBGP neighbor path. Prefer the eBGP neighbor path by eliminating iBGP. But what if both are iBGP? Both are iBGP. What is iBGP? Within an autonomous system. Within an autonomous system, you will have OSPF or EIGRP. See which iBGP neighbor is having less metric to reach, less OSPF metric to reach. BGP will use OSPF metric here. BGP will use RIP hop count here. Because you got 2 iBGP. Both are within the same autonomous system. You need to prefer one. Which one you will prefer? The nearest. How you know it is nearest? By looking into OSPF route. OSPF knows all the internal within the autonomous system network. What if there is a tie in that? Then it prefers the oldest route for eBGP path. Oldest route. Via which route I know for a long time. See, there are 2 routes. Both same kilometer, same wide road, same amount of traffic. And now you want to go, which road you will go? You will go with the road which you know very well for a long time. Because you know every shops in the path. So you prefer to go via the old route which you know first by eliminating the new bridges and new roads that was laid which is similar to the old road. You prefer the old road because you are familiar, every other things are same. Only difference is this road is from my birth. I am seeing this. That road came new. Everyone goes on the new path. Let me go on the new road, old road. So fine, whatever. Just for your understanding, I say that's the old route, means the route which came early as an advertisement which you learned first compared to other routes. For the same destination, I learned a route much early. Prefers the old route for eBGP path. Next, what if both the routes came at the same milli-microsecond? In that case, prefers the path with lowest neighbor BGP router ID. Prefers the path with the lowest neighbor's BGP. Definitely one neighbor's router ID will be different from the other. And when you compare, one will be lower than the other. It prefers the neighbor whose router ID is lower. BGP also picks a router ID like OSPF picks from the loopback interface. If you configure whatever you configured, if you don't configure, it will pick from the loopback interface. So prefers the path with the lowest neighbor route ID. This will be definitely a tiebreaker. Two routers cannot have same route ID. But what if by mistake two neighbors have got same route ID? In that case, it will go with the neighbor whose IP address is lower. This is not at all going to be a tie. This is the best tiebreaker. There cannot be a tie. Definitely one neighbor's IP address will be lower than the other. It prefers the neighbor whose router ID, IP address, whose IP address is lower. Very rare chance router ID to be same. Even if it is same, see the 11th point will be a tiebreaker. There won't be tie anymore. Because in network, every single IP address is unique. One will be definitely lower than the other. So now if you read this point, you will understand better. It eliminates multiple paths and pick only single path. Definitely it can do it. With the help of this attribute. Attributes, you should know this in order. For me, when I learned this first time, I was able to recall maybe up to 6. I remember, yes. Then second time, I was able to remember all 11 of them. That was many years ago, more than 12 years ago. And today, if you ask me, I can say this. It's very easy to say today. But for you to say today may be challenging, but tomorrow you will be able to recall this 11. Twice at least you see this. Or when I finish my lab demo, you will remember all 11 of them. Because I'll be referring every now and then to this page to explain you the path selection. So try to remember this in order. That will make you hero of BGP. All other things that you learned about BGP will not make you a hero. Because you will not know which will be seen first and which will be seen next. So if you want to achieve some path as per the policy, you will know what to tune only when you know this list, which comes first. See, very important page, in BGP. Route selection. Right. So in this chapter we learn about attributes completely. And then in the next chapter we are going to focus on how to use these attributes with policy. We'll have a case study. And when we configure and see as per the case study, when you see the result, you will get a confidence that, oh, I know BGP, I know how to tune these attributes. So just one step more to complete this BGP and become heroes of BGP. One step more, which means it will take at least another 4 days of class to finish that one step. Because you are going to do a big exercise to test all these attributes. So it's going to be big lab week. Today is Thursday, so starting from tomorrow, after BGP comes very interesting topic, MPLS, multi-protocol label switching for all those who have enrolled for CCIE. Yep. Fine, then we'll stop here.